Alright, we're here on the fourth day of Davos, fresh-faced and bushy-tailed at the Inferior Lounge to talk about zero-knowledge proof and the future of the society that we are imagining. I'm Julia Bossmann, I'm at Future Talks and I'm the founder of the Resilience Group. And we're going to make a quick round of introductions and then we're going to dive right in.
So I'm Jonathan Rouach, with a bit more hair than in the picture. CEO and co-founder of QED-it. QED-it is giving zero-knowledge proof to the enterprise world to solve the privacy problem of blockchains. And I'll explain a little bit more about how it works and what we do in a moment.
Hi, my name is Sam Cassatt. I'm Chief Strategy Officer of ConsenSys. I've done a lot of things throughout my life, one of which is be an engineer, computer scientist, cognitive neuroscientist. And so phrases like QED and esoteric mathematical concepts are familiar to me as they apply mostly to business in the blockchain world. So excited to talk about how those concepts actually achieve different business outcomes for us. Thank you.
Hi everyone, my name is David Ernst. I'm the founder and CEO of Liquid US. We're focused on making it easy and trustworthy for peer-to-peer governance in our public democracies as well as in private groups as well. This involves a lot of really interesting privacy questions, and there's a lot of really neat things you can do with cryptography and fancy math, so this is a topic near and dear to my own heart as well.
Cool, and let's do a show of hands with the audience. Who here feels competent that they could explain what zero-knowledge proof is? Alright, that's actually
Then why did you wake up?
more than I expected.
Here.
Don't worry, we're not going to call on you. But for the ones who didn't raise their hands, maybe we can have Jonathan do a quick intro to it, and if you have an example that makes it very understandable for us, then would be great.
Sure. So I came into this field from the cryptocurrency side. My very first company was the Bits of Gold, the largest Bitcoin exchange in Israel. And as these technologies were beginning to be interesting to banks, we started seeing banks asking themselves, how can we adopt blockchain technology if this is based on transparency? Every single actor in the network is going to receive the data, the raw data of the transactions on their node. So I would be sending, Goldman Sachs, I'll be sending to JP Morgan all my clients' transactions. That doesn't work. So the solution to this problem, the most direct and let's say strict solution to this problem is actually using cryptography that's pretty advanced. So zero-knowledge proof is the possibility to prove something on your data without having to reveal that data. And to give an example of how this works, so first of all, why is that a solution? If I have all my transactions and I want to prove that I own an asset, I don't need to reveal where I got this asset. I can prove that I didn't already spend it and that I got it legally, and just share the proof with everybody and not share the underlying transactions. So if I'm capable of doing this, proving without sharing the underlying data, I solve the privacy problem with blockchain. But how do you do that? So at the core, there's zero-knowledge proof. To give a concrete example, there was this contest of Sudoku. So I don't know if you're familiar with Sudoku. You need to have all your numbers 1 to 9 in the rows, in the columns, and in the squares. So there was this big contest, but unfortunately one of the participants wanted to do a prank, and he changed a number in the Sudoku problem, in the hardest Sudoku problem, which meant that those participants worked 48 hours straight to try to find the solution to the Sudoku, and completely failed because there was no solution. And at that point in time, the Sudoku Federation decided we are no longer giving Sudokus to people to solve without proving to them first that there is a solution. Now, how do you prove to somebody that this Sudoku is solvable without revealing the solution to this participant? What you do in real life, you put the solution on a table, you have cards with little numbers on them, and you put the solution facing down on the table, so hidden. I'm the organizer of the Sudoku event. I know the solution, so I'm putting it down. And I only turned let's say, the 2 and the 7 of that hard problem, of that hard Sudoku. So the participant in front of me sees that it's the right problem, 2 and 7. Now, I ask them, challenge, rows, columns, or squares? They say rows. I take the first row, put it in a bag, shake the bag, and give it to that participant. Second row, put it in a bag, shake the bag, give it to the participant. This for the whole 9 rows, so 9 different bags. And they check that in each bag there's all the numbers from 1 to 9. So they see that probably I put on the table the right solution because all the numbers from 1 to 9 are in each and every bag, or each bag is all the numbers from 1 to 9. But they cannot retrieve the order. They don't know exactly how I put it on the table. Now maybe I was lucky and I thought that they would say row, but we can do it again. So I put the solution again, and this time they say square. So I take the first square, put it in a bag, shake it and hand it over. Second square, shake it, hand it over. This way I can convince people that I probably put the right solution on the table, but I never reveal to them anything about that solution. They don't know that what is the private data that I put to solve it. So there is a solution, but you didn't get it. The private data stayed with me, and you can pursue to try to solve the problem.
Thanks for that explanation. Maybe we can take it to the applications now beyond Sudoku. And another way I understood it when we were talking yesterday is that for cryptocurrencies, this has been implemented with Zcash, for example. But you are bringing it beyond cryptocurrency towards all kinds of assets that can be traded on the blockchain. Is that right? So I don't know if this microphone works, but we'll see. So now I would also like to involve Sam and David in talking with us about what are potential other applications on this, and where do enterprise clients or where do maybe constituencies really have a need for privacy or like this kind of information sharing when they want to trade assets?
Sure. So a few comments on that. One word you've probably heard that I think is a really interesting word is ZK snarks. It sounds really weird and unfamiliar, but ZK snark stands for Zero Knowledge Simple Non-Interactive Argument for Knowledge. But I think the end of that is really interesting. It's an argument for knowledge, right? It's not that I actually have the knowledge or that I'm demonstrating the knowledge to you. It's that I have some other thing that allows me to argue that I have the knowledge, right? So another way to think about it is you can selectively choose subsets of information that you might have access to, or that a certain actor might have access to, and then demonstrate to other people that it has that information without necessarily revealing the information itself. So that might be like, I want to demonstrate to the guy at the bar that I'm over 21 years old or over 18 years old, I think, in Switzerland. Or I might want to argue that I have enough money in my bank account in order to pay this payment, and that my bank account is not empty afterwards. You can do those things with things like ZK snarks or things like zero knowledge proofs in general. And I think some of the systems that we're talking about, Zcash, some of the newer Mimblewimble implementations, if anyone's heard of those, are uses of that technology. It's essentially, if I want to send a payment, the payment is not about, like in Bitcoin, I have $100, I subtract $1 and I send it to you, and that's all transparent. It's more about proving that I have $100, and if I send you $100, my account balance won't be empty. That's all the system really needs to know. So there are a lot of applications that look like that. JP Morgan famously developed a platform called Quorum. ConsenSys helped them to develop, actually, which essentially puts an encrypted payload inside of a transaction on Ethereum. And when you send that payload, the counterparties can understand the behavior of that payload. The transaction looks like a normal transaction on Ethereum, but underneath, there's not really the ability for a third-party observer to look at it and see exactly what happened. That same technology has been adapted to looking at bulk transactions in the Ethereum network in general. So anyone who follows Ethereum probably saw in the last couple months or so, Vitalik has been talking about it, a few other parties have been talking about it, the way that you can essentially, you can batch transactions together on the Ethereum network using a zero knowledge proof to show that a number of transactions completed end up having a Merkle proof that is correct, which essentially means that they follow the correct logic of the way Ethereum transaction works, but because they're bulked together and they use this zero knowledge proof technology, it's very less of a load of computation and therefore can reach maybe 500 transactions per second. So the point is, there are a number of applications. A lot of them have to do with privacy. A lot of them have to do with simply the way that any enterprise might want to look at their transactions, right? JP Morgan doesn't want Santander, doesn't want, Goldman Sachs to see their moment-to-moment transaction history. And zero knowledge proofs are a way to abstract away for the system only the stuff that's necessary, only the fact that I can send this transaction, I validly can send this transaction, not necessarily what are the details of all of my account balances and the entire history of my transaction. So it's extremely useful from that perspective.
Sure, I can hop in as well. That was all great, very eye-opening. I'm coming at this really focusing on a particular application area around governance and democracy and citizen engagement. And so the particular privacy questions there are really twofold. The first is, how can I prove that I really am a citizen in a digital space? How can I prove that I live in this jurisdiction, that I am registered to vote, and that my participation is valid? And so traditionally we use a centralized system to do that. You go to your voter registrar, you give them your address, maybe show your driver's license and everything like that. There's some advantage to that system. There's certain disadvantages as well. And of course, it would be much more resilient if we could implement that in a more decentralized way and give all the other participants in the democracy confidence that everyone is legitimate and that you don't have 3 million fake voters from one state or another. And then the other question on the flip side, not just when you're getting into the system to register, but as you're actually participating, you want to weigh in on decisions, and you might want to vote in favor of a particular measure or vote against a particular decision. And sometimes it makes sense for that to be totally public. All of our elected leaders always vote completely publicly, but most citizens, the UN and different groups actually consider it's only a legitimate democracy when you have private voting. The secret ballot is considered core to a legitimate election to protect against things like bribery and harassment and blackmail and your employers are trying to force you to vote a certain way. And so in the same way, in an increasingly digital world, it's very powerful if we can participate and send in transactions that indicate support or opposition, and we can tally to overall support or opposition without revealing individual preferences. So those are the main applications that I'm personally thinking about. I also want to ask a question, if that's all right, to the technical experts here, putting on my application developer hat. What do you see as the drawbacks of implementing zero knowledge proofs? Jonathan, as an expert, I'd be really interested in your take on that.
So if it was free and immediate, everybody would be already using it for years, right? There's been advancement in the field that made it concrete and useful now, but it was invented almost 30 years ago. The co-inventor of zero knowledge proof, Professor Shafi Goldwasser, received a Turing Award just in 2012. That's when it began to get recognition that this technology is actually useful. The drawback of using the technology is that you need a lot of power to produce a proof. So a lot of the work that needs to be done is how do you scale the calculation, the production of a proof? For example, we employ a system where we take the big proof that you need to prove, we chop it into pieces, and we calculate it in parallel so that you can have a proof faster. you need techniques and you need to draw from the use case so that you can reach a level where it's practical in in day-to-day life. You also need it's a big step for industry to accept the magic that's behind it. Why would people trust that type of cryptography? It was considered a little bit like moon cryptography a few years ago. So how do you make sure that people review the different schemes that are out there? So zk-SNARK is one, but there's a bunch of others that are now beginning to pop up. How do you compare between them? How do you convince, or the academics convince themselves of the merits of this technology? And when you apply it to blockchain, the connection needs to be solid. So there's an effort called zkproof.org. zkproof.org is this standardization effort that brings everybody together. I'm kind of pitching it here because the next one is in Berkeley in April. First one was in MIT. It's really the entire ecosystem of zero knowledge coming together and working on those different security, file formats and compilers and interoperability, and then application to protocols, working together to make sure that people can trust the technology and use a sort of standard set of tools.
It's interesting. I think Zcash is the first non-laboratory use of a zero knowledge proof.
And Zcash is part, of course, of that effort.
So what sort of considerations are we talking about when you say different schemes, different trade-offs? What's involved there?
So to give an example, zk-SNARK is the earliest one. It's the one that made it possible to have Zcash and see those assets, or prove that the Zcash asset moved without revealing data. There's an underlying problem with Zcash, which is and it's known, it's public, that at the moment that you do the setup ceremony, there's a lot of trust involved. People need to come together, draw some random numbers, use them, and then forget them. And there's new schemes that are now coming to make sure that that part is no longer necessary.
The actual story of Zcash launching is pretty interesting.
It's amazing.
A number of locations all around the world, maybe 3-6 different computers, filming it in all the locations, journalists in all the locations, making sure that they were doing this correctly. Literally took a saw to the hard drive of each of the computers. Actually, a friend of mine, Morgan Peck, who was one of those journalists, had her phone hacked into live, and it started parroting back the audio of the room to her during it. So there was clearly someone trying to infiltrate the Genesis moment of that. But basically, their key generation moment requires them destroying the equipment that they built it on.
You cannot crank the paranoia button high enough on that. And I'll give you just specifically on what you described. One of our advisors, Ernst, is also one of the co-founders of Zcash. His pet project was cracking the RSA key by using a phone and the phone speaker to hear the variations of the fan, and by that understand what encryption is happening on the computer. So you cannot be enough paranoid, and they did a good job there. But there's new schemes that now put all this to the side, and you don't need to do this ceremony.
zk-SNARKs.
zk-SNARK is one. There's
the setup phase.
Yeah, there's Bulletproof. There's a bunch of others, and all these schemes are now. You need to make sure that you're not losing on security, on performance. So there's a place to compare them now. We're putting benchmarks in place.
And to just add on a tiny bit more context to this setup ceremony, the goal here was to create a cryptocurrency in every way exactly like Bitcoin except private. And if any of these secrets that were created during the setup ceremony were not fully destroyed, anyone that had access to them would be able to print unlimited money for all time without anyone finding out.
Not exactly. It's if
all of them were not destroyed.
Yeah, if the overall
if
secret was so
if
bad.
everybody colluded, you just need one that was correctly made to not be able to recover. But still, they all destroyed their computers, etc.
And you could also decode the previously thought to be private transactions. So they didn't want that to happen. It's possible somewhere, an intelligence agency has a copy of it and can see every transaction ever on a supposedly private network.
No,
And print money for the next thousands of years.
there has been some criticism lodged against Zcash, and then by proxy probably also against the other private ways to exchange on the blockchain. And one of those criticisms is that this is mostly going to be used for criminal uses, because if it was all legal, then it should be trackable and traceable. And this is going to be for the dark money and the dark web and so on. How do you respond to those criticisms?
Well, there's many levels to respond to that. The first level is there's so many applications to the core technology. A lot of them don't go through cryptocurrencies at all, right? You can represent very boring old money on a network. You don't even need to have an open network. You can represent it on those equally boring, I hope, private blockchains. The idea there is, instead of having these ecosystems that work on tokens and token valuation, etc., you can have just the banks collaborate between them and move assets around without those crazy aspects. But I think Zuko himself noticed that we could give selective disclosure of those transactions to a regulator if that was required. And he got a lot of heat on that comment on Twitter later, saying, what was I thinking? But I think he was thinking right. You can have this voluntary gesture of disclosing these last transactions that I can have as if I move Zcash around, and actually prove those what I did, but still not reveal to the other parties what I did. I just selectively prove it to one regulator. As long as you have the core is totally private, you can then, on top of that, build where you want to disclose. Whereas if you start by some disclosure, you cannot go back.
I think privacy in transactions is important in lots of ways, right? I mean, you can think of societies where it might not be okay for a woman to conduct a transaction, for instance. It might not be okay for a journalist to conduct a transaction. And I think there are lots of reasons why privacy could be important to us as a society. The other side of that is complete financial surveillance is a relatively new idea to prevent terrorism. However, I think a few days ago, Danske Bank, and probably pretty much every week in recent memory, a new bank is implicated in laundering, $200 million, $500 million, whatever. I don't think that is a question unique to the technology. The fact that people can hide money, for instance, carry a suitcase full of cash that's probably at least tens of millions of dollars that can fit in a box like this big or so. That's not a new phenomenon. In fact, that's how you, for instance, buy a house in some places in South America, for instance. And so I think it's important that as technologists we don't conflate the value systems of various political actors with the value systems of what a technology enables. And so I think it's a dangerous road to walk down to equate those things.
Yeah, that's very well put, and I absolutely agree with that, that up until recently we wouldn't think of cash being bad for just making our everyday transactions. But with that, it seems like there is some political will, like you said, to make all transactions transparent or traceable. Did you run into any pushback or challenges beyond what you expected in bringing bringing zero knowledge proof into the world because of that political interest?
I think the Zcash example was exactly first example of zero-knowledge proof in production. So it served exactly that purpose of kind of sandboxing of what's possible. What we learned from that is we need to bring the possibility to issue and move assets in a private way now, and this is actually what we did. We launched last week a product that's about asset transfer, integrated to Ethereum, Quorum that was mentioned, but also Hyperledger, Corda, etc. So the idea is that as long as you can see that the technology fulfills your needs, solves the privacy problem of blockchain, the fear that's associated with not being able to know what's in the transaction can go away, especially when you add features like filtering of those transactions with specific business logic that represents regulation. And this is the next level.
Yeah, and I have to say too, from a business perspective, I gave a talk here yesterday about the new emerging blockchain platforms, the properties of Ethereum, why people might want public versus private blockchains. And my argument is always, when people say they want X or they want some new blockchain that they've heard of that I've never heard of that supposedly has a bunch of features, usually what they want is privacy and scalability, right? And JP Morgan Quorum is an advancement towards that. The 2.0 version of Ethereum is an advancement towards that. But these technologies, and actually even already, the primitives in math necessary to do zero-knowledge proofs are built into Ethereum already, because the developers anticipated that people would want to use that technology. So that is a coming part of the feature set of this technology, because any enterprise ever wants it. And JP Morgan doesn't want another bank seeing exactly what they're doing. So we're kind of on an inevitable track towards that being integrated into these solutions. And you might say also, if JP Morgan is entitled to have private transactions, maybe individual citizens are entitled to have private transactions as well. And so it's very difficult to stop the tide of knowledge and technology movement towards that.
Yeah, that's very well put.
We actually had an example that was using Ethereum, the public Ethereum network, to prove your taxes. What's your tax bracket without having to reveal what you hold in every bank account? So we demonstrated that. It's a little bit on his head because you're talking about hiding money, but no, you can use it to keep your privacy on your financial transactions, but still prove that across all your ownings you're in this bracket or that bracket without having to reveal anything. And that was publicly verifiable on the Ethereum network.
There are also some interesting schemes, just to add a little bit more color here, that would allow private messages or private transactions, but a supermajority could actually choose to reveal the transaction itself. So there's an interesting scheme proposed by David Chaum with like an encrypted messaging app like Signal, but the idea is that it gives some sort of, in case of emergency, 90% of the participants could vote to reveal some suspected attackers' messages or something like that.
That's a threshold cryptography.
Exactly.
Thanks for adding that. That brings us also to a question that kind of puts it more into the big picture, and that is, you're all working on these technologies because you have a vision for the future you would like to see. And I'd be curious to hear, what are some pet peeves with how the world works today that you are excited about seeing changing by these technologies?
Well, maybe the first angle is really a practical one. You need to have the tools to use this without knowing ZK snark or circuits of QAPs or pairing or cryptography in general. You want to have interoperable tools that everybody can use to express their business logic and have it just like you have smart contracts in Ethereum, etc. So that's a first one. Those tools are coming, but they require a lot of work to put them. The broader vision for this is ownership of your data. So it's ownership for enterprise and ownership for private individuals. If I can prove to you something on my data without having to share this data, then we move away from consent, which is a little a little bit begging for consent. You already sent the data, and now you ask politely, please don't use it maliciously. No, here you keep the data for yourself. You ask, what do you want to do with it? Give me your formula. I will run it locally. I have control on my data, and now I'll give you just the result and a proof that the result is valid and stems from private data. So I get to control what is being done with my private data, and this is where this is going. It's self-sovereign identity with the possibility to move the proving on my side.
I agree with that. I don't know if it's a pet peeve so much as an observation about the direction of our society, but Facebook, Google, etc. You know, if the product's free, you're the product, and so the dominant business model of the biggest companies in the tech world right now is to take and monetize your data, and the fact that they can do that is an artifact. It's an accident essentially. But it's an artifact of the way that we've architected technology systems so that you emit data everywhere that you go. You emit behavioral data and financial data. That financial data is utilized by people who want to give you loans. It's utilized by political actors who may want to change how much money they want to take from you in the form of taxes, especially depending on the political regime you live under. And so we're going around as humans emitting these large amounts of data, and those data give control of us to other people. They allow other people to monetize and control us. And so to the extent that these things, like technologies like zk-SNARKs, zk-STARKs, et cetera, integrate into our technology platforms, is the extent to which we take back that power in the business model and also in the political implications of that. A lot of the, a lot of the conversation has come up now because of Cambridge Analytica and Facebook, et cetera, but these issues have been present for, since the beginning of these platforms. We've just put a head on it. And I think people also don't realize or think about the fact that that also applies to financial data. Certainly firms that make money off of their financial behavior think about that very deeply. But I think we're moving towards a point where individuals as well as corporations care very much about their privacy of their behavioral and financial data. And this is a way to counter that. And in fact, if those memes get traction, if the anti-Facebook and anti-Google data collection practice memes get traction, I think we'll see a plethora of platforms and technologies and social movements that reject that, actually, and these are the tools of doing that. So I fully anticipate that happening in the next half a decade or so.
Yeah, just to continue the theme, I think it's all about empowering the individual and giving us more control over our own data and just as much our own voice. Again, I'm really focused on the political realm, and if you're plugged into that at all, if you've been paying attention, you'll see a lot of cracks and a lot of somewhat concerning signs. Just one stat is that in the US, the approval rating for Congress has been hovering around 15% for the last decade. Around 9 out of 10 people say they don't approve of our own government. It's actually shut down right this second, as it's been for the last month. So that's cool. But the point is that our world has changed so much, and we've had so much innovation, and we have amazing financial tools now. We can transfer money relatively easily all over the world and buy things with a piece of plastic, and we can trade trillions of dollars on the stock market, and we can get insurance products, and we can get food and so many things delivered to our home, and cars come and pick us up. But the way that we organize ourselves politically is really still based on these ideas from 1776 or earlier times, in an era of pencil, not even pencil, but just paper and quills and horseback riders. And so there's a lot more possible now. We could have ways of organizing that are have much stronger accountability and much stronger protection against corruption, and offer a lot more choice instead of always being stuck in this like lesser of two evils dichotomy that we so often find ourselves trapped in. And so that's what I'm personally really excited about, and seeing some very optimistic signs
Can I ask
of
a
where we
question?
can be going.
It also enables higher frequency of giving your opinion, right? Here in Switzerland, they give their opinion all the time.
That's right. Yeah. In America, for example, we have a 1 bit every 2 years democracy. If you want to talk about in terms of bandwidth, you get the blue team or the red team every few years, versus Netflix is gigabits per second, something like that. So yeah, we could have a lot higher quality feedback and mechanism and things like that.
In Switzerland, actually, in the canton of Zug, we implemented our system Uport, which is an Ethereum blockchain-based identity system, where when you get your government ID in Zug, you also get a complementary Ethereum account identity, essentially. And so we piloted that with them for the first time, voting on a bunch of social issues. And apparently in Switzerland, it's very common, or very important actually, for people to vote on kind of small referendum-like issues, like leaving the EU. But smaller things like fireworks, I think they voted on, stuff like that.
Yeah, I mean, I'm just to put my own opinions out there. I'm all for international trade and bodies like the European Union, but I think the criticism, if there is one there, is the sense of we're being governed by these people far away from us that we don't necessarily feel connected to. We didn't personally choose them. And I think there's a lot of legitimacy to that.
If I can connect to that, just it's a little bit at a higher scale the same problem. You have people that are fighting for their sovereignty. That's fine. You don't want to be affected by other people's decisions, the EU, etc. But at the same time, you want to reach collaboration. So how can you achieve collaboration between everybody but still keep your sovereignty? It's kind of the same problem, but amplified to a larger scale.
Exactly. And I think the important thing is just that these discussions are happening and that there's more alternatives and possibilities being put out in the world, and that we don't feel despair about lack of options or very scary options on other sides of the world, for example.
Yeah, so what I hear from you is a future that we can work towards where the individual has more agency and even communities have more agency. And we no longer have to just be told just to trust the people at the top, that they will have our best interests in mind, and just make ourselves completely vulnerable to whatever they might want to do with our data. And that is a very inspiring future.
Can I add on to that?
Yeah, sure.
And one piece of it is about taking back agency, but another piece of it as well is that there are so many issues that we face as communities, and there's a lot of genuine expertise out there that doesn't have a seat at the table and isn't able to help push some of these things forward. So there's so many problems that we face on city levels and regional levels, on national levels, on global levels, and our current bottleneck system of these 500 people in the room that are really good at fundraising and running campaigns, as we can see, doesn't always necessarily address them as well as models like the open source world, where anyone can show up and propose solutions and debate and get into real nuanced solutions.
Great, thank you. I would like to open this up now to the audience in the last part of this discussion and see if there are any questions or comments in the audience.
It seems so. So if you look at blockchains that put data in the blocks, this is completely counter to GDPR. You immediately let the data go everywhere, and securing the data is also part of GDPR. You have responsibility, even if it's not your firm that's holding the data, you still have the responsibility for the user, for all the places that the data travels. So if you keep the data within your boundaries, you can have at least part of those calculations that you need to perform be done closer to the data, and know that these calculations weren't just invented, they were calculated from the actual data, and all the steps of the calculation were correctly made.
Yeah, I think one of the conceptual framings I hear around GDPR of my friends who have to deal with data is that it essentially makes data toxic. Like, I don't want that anywhere near my stuff. If I can pay someone else to hold it, and I'll only look at it when I need to, and they can be an interface for me. It's a whole business model, is like getting the toxicness of dealing with people's data away from you. And so to the extent that zero knowledge proofs allow you to do that, I think it allows you to only harvest the useful data while technically never having touched it or seen it. I'm unsure how the regulatory framework supports that, but I could imagine in spirit it achieves exactly what they want.
Another way to frame it is how, if the data is local, how do you prove that you're using data that wasn't forged to feed into the system? So it's a bit technical, but the way to solve it is you have two steps to a proof. The first step of the proof is verifying that this data has been seen before. So you have all throughout time hashes of the data put on the blockchain. So it doesn't reveal the data, it's just hashes of the data. And when you go to perform a calculation, the first step is you see this raw data. When you hash it, that hash was previously seen on the blockchain. So I'm not using invented data, I'm using notarized data. So those kids, as they go, the data is not put on the blockchain for further calculation, it's the hashes of the data. And then the first step of the calculation is verifying that that data is valid. So the question is, how do you avoid double spend, and what's the current numbers of scaling of this technology for generating transactions? I would say first there's improvements all the time. So the latest version of ZK Snark is called Growth 16. This is not actually part of the open Ethereum. This version supports transactions that are generated in less than a second without further optimization. Just proving that you didn't already spend the asset takes about a second. It used to take 40 seconds, and this is getting faster and faster. You have this the luck when you're moving to this architecture. Each actor is proving their own transactions, so you have a scaling that comes automatically with that. If I prove, let's say, 10 or 15 transactions per second on my computer or in my network, but there's others that are moving assets and they use their machines to prove their transactions, you end up, if you have 100 actors, having much higher rate of transaction per second than what you used to have on a public regular blockchain, where everybody had to do the same calculation, even if it wasn't for their own transactions. So I use my power to generate my proofs from my transactions, each participant for their own transaction, and you get that scaling automatically with zero knowledge proofs.
I think the point that there's a lot of computation involved is valid, and that provides some sort of architectural choke points for the way you would design a system, but those apply to a very academic set of thinking about it, right? Like one transaction with one computation, et cetera. There have been a few recent advancements that show that you can bulk together, thousands of transactions, use a zero knowledge proof together related to like the Merkle root of it, for instance, and end up with hundreds or thousands of transactions per second, even on like mainnet Ethereum, by using that technique. So yes, the computation is slow. Does that mean the transactions per second is slow? Probably not.
There's another technology that was attempted to solve this problem, which was SGX by Intel, and that didn't fare well for now, but I'm sure they're going to fix for next versions. So you can take different trade-offs to solve this problem, and as long as the efforts of the entire community are focused, you're going to end up with a much higher throughput on one transaction, on one node.
Should we say what SGX is? Is it?
So SGX is a way to take a part of your own CPU, of your own processor on your computer, and perform computations there where you don't really have access to this part of the CPU. It's a little bit like bringing somebody external to sign everything that's being done on your machine. So
And everyone in this room has one of those in their phone. Like when you do the fingerprint scanner or the face scanner or whatever, you're accessing a secure element where it's physically impossible for the software to actually read the private keys.
Allegedly.
Allegedly. I'm sure you could take the thing and cut off a nanometer of it with a scanning microscope and read it if you were the NSA or something and you really wanted to, but it's not worth it for most people.
Why are you looking at me like that?
But SGX was proven to have a bunch of actual flaws in it, and it basically doesn't work.
For now,
That's why it's
again.
interesting,
So
yeah.
they're familiar with the problems for a long time. It's just that putting your security in a physical barrier, you always imagine that bad actor having infinite time, money, energy to try to figure out how to attack that obstacle that's right in front of them. Whereas when you use techniques that are based on mathematics and cryptography, this effort is in the open. Everybody's trying to crack those those schemes, and there's a bounty of $1 billion from Zcash on the first that crack it. So it's a different model.
But if somebody solved that Zcash bounty, would we be able to tell?
Who knows?
You'd probably see a lot of liquidity on exchanges.
Yes.
I have another question for you. So you're working all hard on building these technologies. If we meet again in Davos 2020 in a year from now, what kinds of things you think would we be talking about by then if you succeed?
Well, first of all, there'll be the first users of asset transfer in private blockchain by QED-it. So do go check out QED-it's website. And this is geared towards companies, developers, integrators that need this functionality to be working right now. So we're already working with strategic partners to put it in place. In 1 year, I hope that we can describe what we're doing in insurance, in finance, and other sectors. And I think that the effort, again, to have a common place, a common language to compare all the schemes, to do benchmarking, etc., will have given its first fruits. So people, I think it will attract more developers to this specific field.
I'm not working on a specific project, although ConsenSys is working on a bunch of them. I think this technology will continue to progress, but I think no longer needing to have a conversation with an enterprise that wants to implement this technology and saying, well, isn't all my data public if I put it on blockchain? If that narrative were to change, I think we'd be successful. If Facebook and Google start to sweat about where their data is going to come from, that would feel successful. If people felt that they could give to causes, move money around, and not worry about people surveilling them financially, I think we would also have achieved some of the goals.
A year from now, I'd like to see the number of people that are familiar with liquid democracy and are talking about liquid democracy go up by 2 orders of magnitude, which is pretty achievable because it's still a relatively small number of people right now. We also have thousands of people across the US using our digital democracy tools, and so I think it's realistic to expect that number to climb up to hundreds of thousands as we're starting to partner with a lot of politicians that want to support these methods as well. And in general, just a lot more conversation about what's now possible and how we can use some of these modern tools to really improve our lives for the better and improve our communities for the better.
Can I ask you a quick question? How did the political decision makings get implemented in your platform?
Yeah, so the general paradigm for how we get from where we are today to a liquid future. There's two models. One is known as liquid candidates, and these are people who run for office. I was one of them myself a year ago in California. There have been 15 other people who've gotten hundreds of thousands of votes on the ballot who say that if I get elected, I'll make all of my legislative decisions in office based on what the liquid majority in my local community directs me using these digital tools. And so that's an opt-in grassroots system to transition from electoral democracy to liquid democracy without needing to change a single law. It's similar to the way the blockchain world has created this parallel financial system. People that want to opt into it can opt into it immediately. At the same time, liquid candidates is one vector to achieve this transition. Another way is what we call liquid scorecards. So right now, thousands of people across 48 states in the US are already weighing in on all the sorts of decisions their elected representatives are. For and against bills, nominations, impeachments, and we just automatically send comments on to elected leaders, and then we create transparent scorecards of how much our elected leaders are actually listening to their constituents that voted them in office. And so these two methods work hand in hand. One's descriptivist, here's what people want, here's how much you're following it, and the other's prescriptivist, if we get elected, here's what will happen.
And it's great. It's so obvious that like electoral democracy is based on a dude riding a horse to tell people what the other dude who owns all the land over there thinks, but it takes like a day or two on a horse just to tell other people, as opposed to clicking a button. So we really need to update that stuff. So it's great.
Yeah, the stat is when the system was designed to get a message from New York City to Philadelphia, where the original capital was 4 days on a horse, one direction. To get your reply, whether it got to them, was another 4 days. So that single message written on a quill would take over a week. That's just from New York to Philadelphia. Now think California to the East Coast.
Yeah, exactly. I'm excited towards the future where we can move away from the horse riding based democracy.